Number 3. Number 3 said that if HKL, do you see angle HKL on your worksheet? Is that fully drawn, HKL? Yes, no? Is it fully drawn? No. So the first thing you're going to do is you're going to finish drawing HKL. What did they tell us this? What did they tell us that this measure was for this angle right here? This whole thing. They told us it was 190. If you've got a central angle, what's the measure of this great big arc up here? Measure of a central angle equals the measure of its minor arc. When you have a perpendicular relationship to a chord from a radius, what does it do to the chord? And what does it do to the arc? Bisects it. So if I want to know this measure, how do I get it? I'm going to say 190 divided by 2. If I wanted this measure, how do I get it? 190 divided by 2. If I want this angle right here, how would I get it? 190 divided by 2. They wanted GH, and that is going to be 190 divided by 2. Next question on this worksheet. Yes, Kayla. Number 4. All right, this time they're going to tell us that we've got GH. Arc GH is 80. If this is 80, what's this arc? 80. If this arc is 80, what's this angle? If this arc is 80, what is this angle? If you were asked for this whole arc, what would it be? If you asked for that whole angle, what would it be? Okay, they asked you for arc HTK. So what is this arc right here? 160. Where is HTK? Start at H, pass through T over to K. How are we going to get that? I'm going to take 360, and you're going to subtract 160, and you should get 200. Do I need to see that work? Yep. Next. Brittany. Okay. They told us on number 9, they told us that there's a perpendicular relationship. What do you know about a perpendicular relationship? If this segment and this segment are perpendicular, what do we know about these angles? They're 90. Okay, they just happen to tell us here that K in L happens to be 8x minus 6. Well, what is the measure of that angle? So what's the equation? 8x minus 6 equals 90. And you got to solve it from there. Next question? Yes, sir. 13. All right, we've got HTK. So that's a big arc. Where is it? We have HTK. All the way around there, that is 240 degrees. If this is 240, let me get a different color. What is this right here? How did you get that? Do I have to see 360 minus 240? And that is going to be 120. So if this red angle is 120, then what is each one of these blue arcs going to be? 60. And what is this going to be? 60. What did they ask for? They said GK, arc GK, this arc right here, is 7x plus 11. What is going to be your equation? 7x plus 11 equals 60. I do a lot to my picture before I ever look at what I need to do. Because sometimes you look at the problem and then you start to have a panic attack. I say, okay, 240, what do I know about the arc above? Perpendicular radius means it's going to be bisected, that sort of thing. Any others on this worksheet? Did 3 already. 6. We have HK now to be 100. All right, so we've got arc HK is going to be this one. If this is 100, what is this? That's going to be 50. What is this? 50. What is this? 50. What is this? 50. What else did they tell us? They want the measure of HKL. Where is HKL? They want this angle. What is this measure right here? These are perpendicular. 90. What's the sum of the angles of a triangle? 180. So how do I figure out that angle? We say 90 plus 50 is 140, and then we're going to say 180 minus 140 is what? That's your JKL, HKL. Anything else on this one before I go to the next one? HNL is an angle. HNL. NHL. NHL. Did you need to draw that angle in? Yes, it was not drawn, was it? Just because it's not drawn doesn't mean that you shouldn't put it in there. So we know that that angle is 42. We need to find this big arc right here, HTK. Or do you think you're going to find HTK first? What are you going to find first? We're going to work on what? That arc. So what is that angle right there? It is 90. So if this is 90, can you find this angle X? How? $90 plus 42 is 132, then what? 180 minus 132 is going to be 48. So if this is 48, what's that arc? 48, what's this arc? 48. How am I going to find this green arc? You're going to take 360 and you're going to subtract how many 48s? 2 of them. So that's going to be 360 minus 80, 96, which would be 360, 260, I think that's 264. Any others? Go to page 2. Let's work with problems 1 through 8 first, because my diagrams are on different pages. Okay, there's a diagram for this one. 1 through 8. Any questions? Free? Okay, it says, first of all, let's look at what we're given. We're given NO. NO is perpendicular to MP. Okay, so if you see this it's a radius perpendicular to a chord. What did it do to the chord? Cut it in half. What did it do to that arc? Bisected it. Okay. Then they told us that SQ, and OR are perpendicular. So what did this radius do to that chord? Bisected it. What did it do to that arc? That was from that first worksheet. Okay. Then they're telling us that MP, and I believe that was arc because the arc things didn't show up. On the computer I could see them, but when I printed them it wouldn't. It told us that arc MP, this arc is congruent to this arc. Remember, when you're given congruent arcs, what 2 things are you supposed to look for? Congruent chords and congruent central angles. So these chords are congruent, and if I were to draw in this big angle, it would be equal to that big angle. So what did they tell us? They told us OT is 9. This is 9. They told us PM is 8. If this whole thing is 8, what is this right here? 4. And what they want is OP. It's all sides, it's not angles. What relationship is this? Kayla? So we're going to say leg squared plus leg squared equals x squared. The right angles here, 9 and 4 form it. So you've got 36, just kidding. You've got 16 plus 81 equals x squared, which looks like 97. Let me know if my math's wrong. Pardon? Is it y squared? You mean do you want to square root everything? You mean for Pythagorean theorem? It is, when I teach Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. And the legs of a right triangle form a right angle. So that's what I need you to know so that you do it in the right thing. All right. Why do you have to have plus or minus? Not sure, but 2. All right. Well, I don't know. Does anybody know what this is? That's going to be less than 10, 9 something. 9.85. All right. Next. Leslie, you had a question. Oh, yeah. Number 4. Now, on this problem, they gave you everything in that triangle. But that's not going to be the case. OS is 13. Do we even have OS drawn? So we're going to draw OS, that's 13. OT is 5. This segment is 5, and they want you to find PT, which is this. What is a segment called that starts on the center and stops on the circle? What kind of segment? All right, Kayla? A radius. All right, do you see another radius in this picture? Where? OP. So if OS is 13, what's OP? 13. All right? If this is 5, what is this? Because if you are perpendicular to two congruent chords, they're equidistant from the center. So they're going to give you stuff all over the place, and it's those equal relationships that you have to put together into a single triangle. So what do we have here again? We've got the Pythagorean theorem, correct? So you're going to have 5 squared. Why am I adding x squared and making it equal to 13 squared this time? Why am I doing that? Because x is a leg and 5 is a leg. So you're going to have 25 plus x squared equals 169. Subtract 25, you get 144. And when we square root, how many answers do we get? 2. What's square root of 144? 12. Any others? On 1 through 8. Brittany raised her hand. 2. 2 said QS. Now that's an arc. It said QS is equal to, we'll get rid of this for the moment. QS is equal to 147. If that's 147, what is this from here to here? $73.5. What would this be right from here to here? What would this be from here to here? And that's because the chords are congruent. What do we know about this? All right, what do they want? They said find the measure of angle NOP. Is NOP there? Oh, what's NOP? Central angle, what is it? 73.5. All right, number 6, was that the requested? That was 2. Yes. Did I get it wrong? Oh, wait a minute. On 4, I got 12, but they asked for PT. So if they asked for PT, PT was equal to, was it X? Okay, so I must have missed one. Number 6, we have MP is equal to 4x plus 8. Is MP drawn? MP, this whole segment is 4x plus 8. UQ down here is x plus 21. If that's x plus 21, what is this? X plus 21. Because this chord is congruent to that chord, what is this? X plus 21. What is this? X plus 21. What's your equation? X plus 21 plus x plus 21 equals 4x plus 8. I'm going to let you finish it from there. Let's jump down to the bottom 8. All right, next picture. 9 through 16. Same situation, but instead of the same circle, we're in two congruent circles. Circle C is congruent to circle J. AD is equal to FH, which means you have congruent chords. You've got perpendiculars to both chords, so the chords and the arcs are bisected. Brittany. It says DCB is 43. DCB. If this is 43, what is that arc? 43. What is this arc? 43. These circles are congruent, so what is this arc? And what is this arc? All right, what did they ask us for? They want to find the measure of AD. So what's the measure of AD? It would be 2 times 43, and I should see the work, which is 86. Next. Let's see. 10. AD is 108. I think we're going in the reverse direction here. So now we've got AD to be 108. If that's 108, what is DB? 54. What is this one? 54. What is this one? 54. What is that one? 54. So now it says find the measure of arc GH. GH is right there. What is it? And what should I see? 108 divided by 2. Caitlin, you had your hand up. Yes, you'd have to draw both circles because we're using both circles. So now we've got AB. We have AB to be 8x minus 11. We've got angle DCB. DCB. This angle right there is 5x plus 22. If this angle is 5x plus 22, what's that arc? What did this radius do to this big arc? Because of the perpendicular relationship they gave us? What do you know about those two pieces? So your equation would be 5x plus 22 equals 8x minus 11. All right, it's 7:30. This gives me about 21 minutes to teach. I'm going to come back to the homework and questions after I finish teaching. Okay? All right, so if you look, yeah, you know what? My worksheet's gone because there was a worksheet with it. There's no worksheet there, is there? All right. So does someone have their blue stuff in their notebook? Okay. Let's see how complicated it is. Okay, so let's get page 41 out real quick. Yeah, we're going to try to do this in like 9 minutes. What page? What page? I don't know. What page was it? 41. Page 41. Okay. You got it? You need a compass. And we'll pause the video because you're not going to be able to see what we're doing. Okay. What we have so far, if I haven't messed up, okay. What we have so far is a central angle A central angle is the vertex is on the center, and it equals the arc. What we now have is an inscribed angle, and it takes two angles to equal the arc. So let me go to the notes. Okay, inscribed angle is an angle whose vertex is on the circle. On the circle. And whose sides are chords of the circle. Central angle, vertex on the circle, and the sides are chords. The intercepted arc, that means this arc right here, is the arc whose endpoints are on the intercepted arc is the arc whose endpoints are on the endpoints of the inscribed angle. This is my intercepted arc. Where the rays cut off that arc of that angle, so it's an inscribed angle. Inscribed angles do not equal the arc. Central angles equal the arc. Can you put your compass down? Take notes. Later, I want you to pay attention. Inscribed angle is an angle whose vertex is on the circle, whose sides are chords. The intercepted arc is the arc whose endpoints are on the endpoints of the inscribed angle, or on the rays of the inscribed angle, or on the sides of the inscribed angle. It's all about the vertex. Where is the vertex? Is it on the center? Is it on the circle? Can you see? Second, measure of an inscribed angle in a circle is equal to half the intercepted arc. If you have two angles, inscribed angles that intercept the same arc, they're equal or congruent. So, inscribed angle is equal to half the arc. Central angle equals the arc. Tomorrow you'll learn two more. Two more. It's all about where the vertex is. Is it on the center? Is it on the circle? Blue things tomorrow. All right. For all circles whose vertex is on the circle, their measure is half the arc. I'm just saying this over and over and over again. So look at this funny looking angle. Is its vertex on the circle? This is the arc it cuts off. So if I told you that that arc was 300 degrees, how would we find that angle? What are we supposed to do? Half the arc. So this angle would be 300 divided by 2, or 150. Doesn't equal the arc anymore. It's half the arc. Or you could say the arc is double the angle, if you don't like fractions. So I believe you're back in the book. Notice, I believe, what was your homework assignment yesterday? 51, 52? We're skipping 53. We're going directly to 54. All right. So if we want to look at this, and that's, let me come back to here and draw some more circles. Okay. So here, if I have this circle, and I tell you that this is a diameter, and I give you this, and let's say we do this, that goes up there. If I tell you that this is 80 degrees, what is this arc right here? This is a diameter. I heard it. Well, why is it 100? Right. Is this not a semicircle? Which is half of 360, so this is 100. If I told you this is 60, what is this arc? 120. All right. So now let's look at our angles. What's the measure of this angle right here whose vertex is on the circle? It is 60. Arc equals angle. Look at this vertex. Follow its sides. What arc does it cut off? What arc? 100. Vertex is on the circle. What's the measure of the arc? What's the measure of the angle? Half. So if that's 100, what's that angle? 50. Where is this? Let me get a different color. There's a vertex on the circle. Look at that angle. Follow its sides. What does it cut off? 120. What is the measure of this arc angle? 60. Half of it. So if we look at this picture, we're going to determine all arc measures first. This is a diameter. So if this is 80, what is this arc? 100. If this is 60, what must this be? 120. Kind of like what I just did. All right. If I want measure of angle 3, that's the center of the circle. What is measure of angle 3 then? It is 80, because when you're on the center, the measure is the arc. All right, let's look at 4. What does 4 cut off? It's really helpful. Yes, it cuts off 60. Sometimes it's helpful to take pieces of paper and follow the side, so all you see is what's cut off. So how do I get the measure of angle 4? It's going to be half of what? Half of 60, which is 30. Up equals 30. All right, what about angle 5? Where's 5? Here's 5. We know 4 is what? 30. Let's look at 8. What's the measure of angle 8? Vertex is on the center. 120. So if 8 is 120 and 4 is 30, how am I going to get 5? Do you see a figure here? What kind of figure is that? Triangle. So how do we get the measure of 5? What are you going to do? You're going to say 30 plus 120 is equal to what? 150, and then what do we say? 150 minus, or 180 minus 50 is 30. So this is going to be 30. What about measure of angle 6? Where's its vertex? Where's the vertex? On the circle. What does it cut off? 100. So it equals the arc. Let's look at measure of angle 7. Where is 7? 7, where's the vertex? Where's the vertex? On the circle. Follow its, we can't get that. We know this is, okay, 7 we can't do yet. What about 8 we did? 9 we can do. What's the measure of angle 9? Where's its vertex? On the center. So what's the measure of angle 9? 60. 10 we need tomorrow. So hopefully, I believe this section was only inscribed angles. It's only about inscribed angles. So if you have an angle inscribed in a semicircle, doesn't it cut off 180 degrees? So what will that angle be if its vertex is on the circle? Half of 180 or what? 90. All right, you're going to need this tonight. It's in your book. Opposite angles of a quadrilateral, meaning angle 1 and angle 3, are going to be supplementary. What does supplementary mean? They add to 180. So if angle 1 is 110, what is angle 3? 70. If angle 2 is 90, what's angle 4? 90. So you'll need that. All right. What's your homework? For those of you who